In Learning Objective D, we're going to talk about how to use the calculator to do the permutations. Let's talk about the spaces method again. So here we have an art gallery with 12 paintings, but only enough room to put 8 of them up. How many different ways can you do that? Well, this is going to be 12, choose 8, which means we have 12 items, but we're only going to pick 8, so I'll do 8 spaces. If you do the spaces method, we're going to have 12 choices. Once you hang up one picture, it's not going to be available, so we're down to 11. And we go all the way down to 5. If you compute this out, you're going to get that there are 19,958 400 ways to actually hang these paintings. Now on the calculator to do it, it's very easy. You're going to find there is a button. When you click math right here, you click math, and then you're going to have to use the right arrow key to arrow over to probability. And NPR is right here. Now to type it in the calculator, you first would have to start and type 12. Then you go to the calculator and you do the math, scroll to probability, click NPR, and the NPR button is going to show up. Then you would end it at end and type the number 8. When you do that, you will get this answer. Now you also have the choice of using the graphing calculator to use the formula we talked about. If you did 12, choose 8, it'd be 12 factorial over 12 minus 8 factorial, which is 12 factorial over 4 factorial. Now on the calculator where you're going to find that button, you're going to see it right here, a few spaces under NPR. So to access that, you would just do math, and then you're going to scroll over to probability, and then what you would type on your calculator screen, you would do 12, then the factorial button, then you'd come on in here and do the division sign, then you would go back and you again would do math, probability, and get ready to type in 4 factorial, so that in 4 factorial, and you'll get the same answer. So there are 3 ways to actually do this problem. Using the spacing method, using the 12 choose 8 method directly on the calculator, or using the formula with factorial and then typing in the 2 factorials. Okay, in this example, we're going to look at the scenario that there are 17 students. They argue who gets to be first in line. In karaoke's class. So he decides to put the students in a different order every time they get in line. He decides to list all the possible orders so he will not have any duplications of them. If he takes him 20 seconds to write down each order, how long is it going to take him to finish this list? And the question is it reasonable for karaoke to make a new list for all 17 students every time? Well, if you think about it a few ways, if we did the spaces, you know, there's going to be 17 students in line, so you're going to go ... over to the 17th. So the list would be 17, 16, 15, 14, all the way down to 1. Now look at the pattern here. Keep in mind what we call this. If we take 17 all the way down to 1 and multiply, that's actually 17 factorial. So on your calculator, what you can do is do 17 factorial, and here's the number you're going to get. Okay. It's incredibly long. It's going to be over 355 trillion different orders. Now, to figure out how long it's going to take them, if you times that by 20 seconds per list, and then you compute this in terms of time, and you go into years, I'll tell you this. It's going to take him over 200 million years to actually make this list. So he is by far not being reasonable in this situation. Okay, let's take karaoke's 17 students and mix them up a bit. This example here, he decides to put 6 girls in his class first, and then the 11 boys. How many different orders would he have for this? Well, again, let me show you the spaces way and the shorthand calculator way. The spaces would say there's 6 girls, and then we'd have 11 boys. If you think about how you'd fill the spaces in, if there's exactly 6 girls, this would be 6, 5, 4, 3, 2, 1. And then for the boys to fill them in, that'd be 11, 10, 9, all the way down to 1. So a couple things you could do. If you use the calculator, you could say it is 6 factorial times 11 factorial. Or you could break it down and just look at the girls first. Okay, if we do the NPR button, he's going to do 6, NPR 6. 6 girls choose 6. And then for the boys, there's 11 boys. Then he's going to do NPR, choose 11. This calculation right here is the same as 6 factorial, and this is the same as 11 factorial. The answer we're going to get for this is going to be 28, 740, 096, 000. So 28 billion. So his list got a little bit shorter. So part B is the answer to part A greater than, equal to, or less than the answer that we did before. Clearly, this is a smaller list, but is still quite unreasonable to make a list for every single order.